Assalamualaikum and good morning to everyone. Today my group will present about Colpitts Oscillator. This presentation will be presented by me, Muhammad Asal Basri bin Muhammad Noor, Muhammad Arif bin Kamal, Danish Farhan bin Harzul Fazli, and lastly Muhammad Shafiq Ashraf bin Wan Abi Malik. Before we start, we must know who invented Colpitts Oscillator and what is Colpitts Oscillator. A Colpitts Oscillator invented in 1918 by Canadian-American engineer Edwin H. Colpitts using vacuum tubes is one of a number of designs for LC oscillator. Electronic oscillator that use a combination of inductor and capacitance to produce oscillation at a certain frequency. So, what is Colpitts? The Colpitts oscillator is very similar to Hartley oscillator, but Colpitts use two capacitors in the tank circuit instead of tap coil. You can change a frequency of Colpitts either by varying the inductance of a coil or capacitance of two capacitors in the tank circuit, and the tank circuit determines the frequency of oscillator. The tank circuit consists of two series connected capacitors in parallel with inductor. The two capacitors will act as capacitance voltage divider across the inductor. The resistance ratio of two series capacitor is usually chosen to match the input-output resistance of the transistor used.
For circuit diagram, we have two types, that is basic Colpitts oscillator and Colpitts oscillator using op-amp. Firstly, in basic Colpitts oscillator, we can see it have bipolar junction transistor BJT. The emitter terminal of the transistor is effectively connected to the junction of the two capacitors C1 and C2 were connected in series. An inductor L is connected parallel to the serial combination of the capacitor C1 and C2. It will be LC tank. Resistor R1 and R2 provide the usual stabilizing DC bias for the transistor in the normal manner. The additional capacitor C3 and C4 act as a DC blocking bypass capacitor. A radio frequency choke RFC is used in the collector circuit to provide a high reactance ideal open circuit at the frequency of oscillation. After that, we have Colpitts oscillator using op-amp. For this circuit, the BJT will change with the op-amp. Resistor R1, R2, and R3 will connected to the negative input op-amp, and inductor L is connected parallel to the serial combination of the capacitor C1, C2. It will be LC tank. The LC tank will also go to the negative input of the op-amp. The positive input of the op-amp will go to the ground.
So, for now, I will explain about operation of the circuit. Firstly, to running the circuit, it must be connected with AC power supply as is voltage source. And then, the oscillatory current in the tank circuit will produce AC voltage across capacitor 1 and capacitor 2. After the capacitor get fully discharged, the electrostatic energy that stored in the capacitor will transfer to the inductors. Same thing will happen when inductor getting discharged. Capacitor will start charging, and this process will continue, causing generation of oscillation. Also, the frequency of the tank circuit can be determined by using resonant frequency. About the tank circuit, the tank circuit can be considered as energy stored. Is because of continuous charging and discharging process between capacitor and inductors that forming the tank circuit. So to sustain the oscillation, The total phase shift must be 3600 or 00, and the feedback voltage is 1800. The emitter transistor also produce 1800 phase shift between input and output. This will cause a continuous oscillation.
Okay, so now I want to talk about important formula for the Colpitts oscillator. The important formula for the Colpitts oscillator is the frequency of the oscillation. The formula is F equal to 1 per 2 pi square root LCEFF, where L is the inductance of the tank circuit and CEFF is the effective capacitance. So, the derivation of this formula involves analyzing the feedback network formed by the capacitors and the inductor. So, this is simplified derivation. The first is analyze the equivalent capacitance when capacitor C1 and C2 are in series. The total capacitance C equivalent is given by 1 per C equivalence equal to 1 per C1 plus 1 per C2. The second is the equivalence capacitance C equivalence is in parallel with the inductance L, forming the tank circuit. This form a parallel LC circuit with resonance frequency FO given by FO equal to 1 over 2 pi square root LC equivalence. So now simplify C equivalence into an effective capacitance CEFF, which represents the feedback capacitors in the oscillator circuit. This is done by using the formula FO capacitors in series, that is CEFF equal to C1 times T2 per C1 plus C2. And lastly, substitute CEFF into the resonance frequency formula to obtain the final expression for the frequency of oscillation, that is F equal to 1 per 2 pi square root LCEFF.
Then we need to know the application of the Colpitts oscillator. First, it used to generate of sinusoidal output and high frequency. Second, the Colpitts oscillator using SAW device can be used as a different type of sensor, such as temperature sensor. As the device used in the circuit is highly sensitive to interface, it sends directly from its surface. Third, it frequently used for application involving a very wide frequency range. Fourth, used for application where undamped and continuous oscillation are required to function. Fifth, this oscillator is preferred in situations where it's intended to withstand high and low temperature frequently. 6. The combination of this oscillator with some device instead of tank circuit can be used to achieve great temperature stability and high frequency. 7. It is used for the development of mobile and radio communication. Lastly, it has many applications used for the commercial purpose. That's all for us. Thank you very much for listening to our presentation. I hope this presentation can help you know more about Colpitts oscillator.